Hello guys, welcome to my channel. Today in this video I will discuss about coupling and decoupling capacitor. So let's get started. First of all, let me explain what is the coupling capacitor. So basically I am considering two devices, device A and device B. So this is the coupling capacitor placed in series between two devices, device A and device B. So coupling capacitor will pass only AC signal from device A to device B, and it will block the DC signal. So you can see the AC signal is passing from device A to device B and it's blocking the DC signals. You can see the input and output. So this is the input before capacitor and this is the output after capacitor. So in this graph it contains DC and AC both signal, and in the output side it contains only pure AC signal. So this is a mixed AC and DC bias, and this is only pure AC signal. So a coupling capacitor is used to pass AC signals from one circuit to another and blocks DC signals. A coupling capacitor maintains AC signal on both circuits. So it will maintain AC signal on both circuits. A coupling capacitor makes couple on both sides. Therefore, it's called coupling capacitor. So it will couple only AC signal on both sides. That is why it's called coupling capacitor. So now let me explain about decoupling capacitor, or you can say bypass capacitor. Okay, so here I am taking two devices, device A and device B, or circuit 1, circuit 2, whatever, it depends, up to you. So this is the decoupling or bypass capacitor, which is placed in between supply and ground. So decoupling capacitor is always placed in between supply and ground. So this is the decoupling capacitor. So now decoupling capacitor will allow only DC signal from device A to device B. So you can see here that DC signal is passing from device A to device B and it will block AC signal. That means it will passes AC signal to the ground. As you can see here, the decoupling capacitor is passing AC signals to the ground and it passes DC signals from device A to device B. So this is the input before capacitor. This is the output after capacitor. So in the first graph, this is the mixed signal AC and DC bias, and this is the pure DC signal. So DC signal should be straight line. So this is the DC signal. A decoupling capacitor allow only DC signals from one circuit to another and it will decouple, bypass AC signals to the ground. As you can see here, it will bypass AC signal to the ground. A decoupling capacitor maintains DC signals on both circuits. So the decoupling capacitor will maintain DC signal on both circuit A and circuit B. A decoupling capacitor decouple or bypass AC signals to ground. So the decoupling capacitor will bypass AC signals to the ground. So therefore it's called decoupling or bypass capacitor. So now place of decoupling or bypass capacitor. So you should remember that the bypass capacitor should be placed near the pin. As you can see here, a decoupling capacitor is placed between the power supply and ground as close as possible to the pins of an IC. As you can see here, this is the supply pin and this is the ground. So also this is the closer to the power pins. So you should always keep the decoupling capacitor as shown as closer to the power pin. Okay. So now where it's used, where we can use the coupling capacitor. Where we can use the coupling capacitor in amplifiers or signal processing circuits between two stages, two transistors or op-amp stages. Example, if an audio amplifier's output has a DC bias but the next stage shouldn't receive DC, a coupling capacitor is placed between them. What is the typical value of coupling capacitor from microfarad range? That means 0.1 microfarad to 10 microfarad for audio and low frequency circuits depending on frequency response. What is the advantages of coupling capacitor? It prevents DC interface between stages, maintain correct biasing of transistors or op-amps. So now where we can use the decoupling capacitor. So decoupling capacitor can be used near ICs, microcontrollers or op-amps across the power, VCC and ground pins. What is the typical value of decoupling capacitor is 0.1 microfarad ceramic capacitor for high frequency noise, 10 microfarad or 100 microfarad electrolytic capacitor for low frequency stabilization. What is the advantages of decoupling capacitor? It reduces voltage spikes and noise, ensure stable operation of ICs and analog circuits. Thank you.